Sometimes the hardest part about any kind of design project is getting started. You're sitting at a blank sheet of paper, you know a truth table you want, and you have no idea how to put a bunch of gates together to make the circuit happen. One possible solution to that is to use a technique called OR of ANDs, otherwise known as brute force. Let's see how that works. So here's a truth table. You should recognize it. And we're going to try and create a circuit using nothing but ANDs, ORs, and NOTs to implement this circuit. No cheating by using an XOR gate. Our first step is to find all the ones in the output. Well, there's two of them, and they're highlighted here. That was easy. Our second step is to write an AND expression for each input or input NOT that leads to that result. Now in the first row we see that A is a 0 and B is a 1. If I wrote the expression A NOT B, A NOT is 1, B is 1, and those together, and I get a 1. Notice that no other row would A NOT B give me a 1. Now in the other row, I have A and B NOT that yields a 1. Again, no other row in the circuit A and B NOT would yield a 1. Because each of those only, if you want to think about it, turns on for one specific row, if I OR them together, I will find an expression that turns on just for the rows that I want it to. So X could be implemented with a circuit that corresponds to A NOT B plus A B NOT. This circuit would be called an OR of ANDs. I AND a bunch of inputs together, one for every time I've got a 1 in my output, and I OR all of those ANDed terms together. OR of ANDs. And as I said, that's a circuit we've seen before. It's an XOR. So this OR of ANDs provides us a way to implement an XOR gate using nothing but ORs and ANDs and the occasional NOT gate. Let's do it. I'm going to work backward for this, starting with the OR gate that's going to be my final output. And of course I've got my two inputs, A and B. Now going into that OR gate are going to be two AND gates. Those AND gates are ORed together. That's the OR of ANDs. And now I need to look at the inputs going into each one of those AND gates. I'm actually going to look at it one input at a time. And we'll first take a look at input A. A NOT goes into the first AND gate. And A goes into the second AND gate. B is the reverse of that. B goes into the first AND gate, and B NOT goes into the second AND gate. Now just in passing, I'll note that that little equation up there, or maybe that identity, looks like something important in algebra. And indeed it is. It's in effect the definition of the symbol XOR, the operation XOR, in Boolean algebra. More on that to come.